Hello everyone, this is Ketish here. In this video, I'm going to go through the AQA Chemistry Paper 1 Higher Tier from 2025. Question number 5 is on the topic of atomic structure and the periodic table. This question is about small particles. Before the discovery of the electron, atoms were thought to be tiny spheres that could not be divided. The discovery of the electron led to the plum pudding model of the atom. Describe the plum pudding model of the atom. Now, if you remember, the plum pudding model of the atom is actually drawn like this: a sphere with a positive charge and electrons embedded on it. So first point, a ball of positive charge with, second point is with negative electrons embedded in the ball of positive charge. The model of the atom changed again after the alpha particle scattering experiment. Give two conclusions that were made from the alpha particle scattering experiment. Now, there's about 4 different conclusions that you can write. So, first one, the mass of the atom is concentrated at the center, which is the nucleus. The second point is that the nucleus is positively charged. The third one is the atom is mostly empty space. And you could also say the fourth point is the electrons orbit the nucleus. Now, you don't want to refer to the shells here because reference to the shelf is the next model. Niels Bohr made another change to the model of the atom. What is this changed? Right, that's the change. The electrons orbit the nucleus. At specific distances. Which we can refer them as energy levels or in simply as shells. A helium atom has a radius of 1.4 times 10 to the power minus 10 meters. The nucleus of the atom has a radius of 1.7 times 10 to the power minus 15 meters. How many times larger is the nucleus of the atom than the nucleus of the... how many times larger is the radius of the atom than the radius of the nucleus? So, this you would want to divide 1.7 times 10 to the power minus 15 divided by 1.4 times 10 to the power minus 10. And it would be about 100,000 times larger. Nanoparticles contain few hundred atoms. Figure 5 represents a cubic nanoparticle. So it's 1.2 nanometers, the length, width, and the height. Calculate the simplest surface area to volume ratio of the nanoparticle. So we can keep them in nanometers. So surface area, each side is 1.2 times 1.2, and there's 6 sides, so multiply that by 6. So that would be, so let's square this, 8.64 nanometer squared. Volume is length times width times the height, so that's 1.2 times 1.2 times 1.2, or you could say 1.2 cube, which is going to be 1.728 nanometer cube. So ratio is, for surface area to volume ratio, is 8.64. 8.64 is to 1.728. So if I divide 8, that again into semicolon, 8.64 divided by 1.728, that should give you about 5. So that's 5 is to 1. I've rounded this off to 5. So lenses in reading glasses often have a scratch-resistant coating that contains a hard substance. Nanoparticles of the hard substance are used instead of the fine particles of the hard substance. Explain why nanoparticles are used instead of fine particles. Well, we could use the answer that we got from the previous question. The nanoparticles have a higher surface area to volume ratio. So less coating is used in making the glass, or you could say a thinner coating can be used. Or you could say a thinner coating is used, which means more light gets through the lenses because it's a hard substance. That brings us to the end of question number 5, and I will see you in question number 6.